Tonight, you'll set your baby down in a room by themselves. A soft mattress, a monitor humming quietly on the shelf, the door pulled shut behind you. It's routine. You won't lose a second of sleep wondering if it's safe. Your ancestors would have called that a death sentence. For nearly the entire history of our species, an infant left alone after dark simply didn't see morning. There was no monitor, no nightlight, no number to call if something went wrong. Just open darkness, dropping temperatures, and predators that could pick up the scent of a newborn from hundreds of yards away. This wasn't a rare danger, it was the nightly reality for every parent who ever lived before us. Over 300,000 years of it, generation after generation, facing the exact same impossible problem. Humans are born as the most defenseless creatures on Earth, and figuring out how to keep one alive may be the single hardest challenge our species ever solved. The answer to how they pulled it off doesn't just explain ancient survival, it rewrites what you think you know about family, about instinct, and about what your own body was quietly built to do. So let's start with the problem, because the problem, honestly, is you. A foal stands on its own legs and walks within hours of being born. A baby chimpanzee is born already strong enough to grip its mother's fur and hang on. A human newborn can't even hold its own head up. It won't walk for a year, it can't feed itself for years after that. Left alone for one night, it has no chance at all. Out of every primate on the planet, human infants arrive the least finished, and the reason comes down to your brain. Your brain is so large that if it grew inside the womb to the same proportion a chimpanzee's does, birth would be physically impossible, so evolution cut a deal instead. Human babies are born with a brain at roughly 25% of its adult size, compared to about 40% for a chimp. That leaves 75% of your brain to finish developing after you're already out in the world, completely unable to protect yourself. This isn't a flaw in the design, this is the actual cost of the design. You get the most powerful brain on Earth, in exchange, you get the most helpless infant on Earth. And for 300,000 years, that was the equation every mother had to solve. A baby that couldn't cling to her, couldn't run from danger, couldn't even stay silent when something was circling close by. In a world stalked by leopards, hyenas, and snakes, that baby wasn't precious cargo everyone protected out of sentiment. It was a target. So how, generation after generation, did any of them survive? That's exactly where we're headed. And if questions like this are the kind you want answered, hit subscribe now, because we're about to get into it. Here's the thing about chimpanzees. A mother chimp does this alone. If another female so much as reaches toward her newborn, she'll bare her teeth and pull away. In the entire primate world, solo mothering like this is the rule, not the exception, which makes what happened with humans genuinely strange. Because a species with the most helpless infant on Earth should have doubled down on solo protection, not given it up. Instead, we did the opposite. Humans became the only great ape where mothers routinely hand their newborns to other people. Sisters, grandmothers, cousins, even unrelated neighbors within days of birth. Anthropologist Sarah Hrdy spent decades studying this pattern, and her conclusion reframes the entire story of human infancy. She argues that a baby this defenseless could never have survived on maternal care alone. It required what researchers call cooperative breeding, a system where raising a single child is treated as a shared, non-negotiable group project, not a private task for one exhausted mother. This isn't a guess. It's measurable in the groups anthropologists still study today. Among the FA people of the Congo rainforest, researchers tracked how often infants were held during their first weeks of life. The number is almost hard to believe. Up to 14 different people held the same baby within an 8-hour stretch. And the mother? She accounted for less than half of that holding time, often closer to 40%. The other 60% belonged to everyone else. Among the Aka people, researchers found fathers spending as much as 47% of their day within arm's reach of their infant, a level of paternal closeness almost unheard of in the rest of the animal kingdom, let alone the rest of the great apes. Line these two facts up and the logic becomes obvious. A brain that finishes growing outside the womb needs constant, uninterrupted physical protection, something no single adult can provide without eventually sleeping, eating, or foraging. So evolution didn't just hand mothers an impossible task and hope for the best. It restructured human social behavior around solving that exact problem. The tribe became the nursery. The child was rarely, if ever, set down alone because in a landscape with predators at every edge, alone and at risk meant the same thing. This is worth sitting with for a second because "it takes a village" isn't a warm saying someone invented for a greeting card. It's closer to a biological requirement hardwired into how our species reproduces at all. The mother's body could grow the brain. It took an entire group to keep that brain alive long enough to finish growing. But holding a baby constantly creates its own problem. Someone still has to walk, forage, climb, and work, all while keeping this fragile, immobile creature safe and off the ground. Which raises the next question. If you can never put the baby down, how do you get anything done at all? Here's a problem most people never think about. A baby chimpanzee doesn't need to be carried. It carries itself. Its grip is strong enough to hang from its mother's fur while she moves through the trees, hands-free, no extra effort required on her part. Human mothers don't have that option, and the reason traces back to a decision our bodies made over 1 million years ago: walking upright. Once our ancestors committed to standing on 2 legs, natural selection stripped away the thick body hair that other primates rely on for infants to grip. Less hair meant better heat regulation for a species now running and sweating across open landscapes. But it also meant something else, something with much higher stakes. A newborn human had nothing left to hold on to, no fur to grip, no fallback. If a mother's hands were busy, foraging, climbing, fleeing, the baby couldn't cling on and come along for the ride. So humans did something no other primate had to do. We invented the solution instead of growing it. We built a tool. This isn't speculation. Archaeologists working a roughly 10,000-year-old infant burial site in Italy, known as the Neve burial, found the remains of an infant surrounded by more than 1,000 tiny shell beads, arranged in a pattern consistent with a decorated carrying wrap or sling, not scattered as loose ornaments. That's not a small detail. It suggests that infant carrying tools weren't a modern convenience. They were considered important enough, sacred enough to bury a child with one. But the sling only solves half the equation. The other half is written into the baby's own nervous system. Researchers studying infant behavior have observed something now referred to as the transport response. When a baby is picked up and carried, movement, even a simple side-to-side walk, often triggers an almost immediate drop in heart rate and crying. The infant's body seems to shift automatically into a calmer, more passive state the moment it's held and in motion. Scientists are still working out exactly how far this reflex extends in humans, since most of the detailed evidence comes from animal studies, with only limited human research backing it up. But the pattern itself is easy to observe, because you've probably watched it happen yourself. A crying infant that goes quiet within seconds of being lifted and walked? Put these 2 pieces together and the logic lines up cleanly. Losing body hair created a crisis, an infant that could no longer transport itself. Culture answered with an invention: the carrying sling. And biology met that invention halfway, wiring infants with a built-in incentive to stay calm once they were in it. Tool and instinct, evolving to solve the same problem from 2 different directions. And that reflex didn't disappear when the danger did. It's still sitting in your own nervous system right now, in every baby quieted by nothing more than a walk around the room. But carrying a child solves the problem of protection. It does nothing to solve the problem of feeding one. For years, without a single trip to a store. Picture the options available to a mother 300,000 years ago the moment her baby needed food. No formula, no blended purees in a jar, no clean boiled water to mix anything with, even if she had it. In a world like that, there was really only one reliable source of nutrition, and it had to come from a human body. That's why breastfeeding in ancestral populations didn't last months. It typically stretched on for 2 to 4 years. This wasn't a lifestyle choice or a bonding ritual. It was closer to a survival requirement. Breast milk was sterile in an era when nearly every other water source carried disease. It delivered antibodies that a fragile immune system couldn't yet produce on its own. And it was, quite simply, the only food source available that an infant's body could safely digest for the first year or more of life. There's a second layer to this that's easy to miss. Prolonged, frequent nursing suppresses ovulation in many women, acting as a natural form of birth spacing. Researchers refer to this as lactational amenorrhea. It's not a perfect contraceptive, but across ancestral populations, it functioned as one of the only tools available for spacing pregnancies years apart. And that spacing mattered enormously. A mother caring for one fully dependent infant already had her hands full. Adding a second at the same time could put both children's survival survival at risk. So the same act that fed a baby also protected the timing of the next one, giving each child a longer stretch of undivided care before a sibling arrived. But nursing alone couldn't carry a growing toddler all the way to independence. At some point, a child needs solid food, and solid food creates a new problem. An infant with no molars can't chew meat, roots, or tough plant fiber. Ancestral caregivers solved this the only way available to them, by chewing it first. Mothers and grandmothers would break down tough food in their own mouths, softening it into something an infant could safely swallow, then pass it directly from their mouth to the child's. Anthropologists call this practice pre-mastication, and it shows up across hunter-gatherer societies worldwide. It wasn't unusual or extreme. It was standard infant feeding technology built entirely out of the human body. And this is where one more idea comes in, a genuinely interesting one, though it's worth being upfront that it remains a theory rather than settled fact. Some anthropologists have proposed that this mouth-to-mouth feeding practice may be one contributing origin behind human kissing, arguing that the intimate, mouth-focused contact of pre-mastication could have shaped later affectionate behavior between caregivers and children, and eventually between adults. It's one hypothesis among several competing explanations for the origins of kissing, not a settled conclusion, but it's a striking possibility. So nursing kept infants alive and spaced their siblings apart. Pre-mastication carried them the rest of the way to solid food. Together, they solved feeding for the first several years of life. But none of this explains one of the strangest facts about human biology. Why would evolution keep an unrelated older woman alive and healthy for decades after she can no longer have children of her own? Across almost the entire animal kingdom, female reproduction and female lifespan are the same thing. A chimpanzee, an elephant, a lion, once a female stops being able to reproduce, her body doesn't linger for decades afterward. In evolutionary terms, there's no obvious reason for it to. From the cold logic of natural selection, an individual who can no longer pass on genes shouldn't have much biological purpose left in continuing to burn resources and survive. Human women break this rule completely. Menopause typically arrives in a woman's late 40s, yet healthy human females routinely live 3, 4, even 5 decades beyond it. No other primate does this. For a long time, this looked less like a feature of human biology and more like a flaw, as if evolution had simply failed to shut something off. In 1997, anthropologist Kristen Hawkes, working with the Hadza people of Tanzania, proposed an explanation that flipped the question on its head. She and her colleagues spent time observing who was actually feeding the group's children, and the data pointed somewhere unexpected. It wasn't the mothers doing the heaviest lifting, it was the grandmothers. Hawkes documented older Hadza women spending long hours digging for tubers, deep-buried root vegetables that take real strength and skill to extract from hard, dry ground. These older women weren't just capable of the work, they were often more productive at it than younger mothers who had a nursing infant pulling at their attention and their energy. The food these grandmothers brought back didn't go to themselves, it went straight to their grandchildren and their weaned children, filling the nutritional gap the moment a child stopped breastfeeding. This became known as the grandmother hypothesis, and the logic behind it is elegant once you see it laid out. A woman who kept having children into her 60s would be gambling everything on one fragile, unfinished infant at the exact age when her own body was breaking down. But a woman who stopped reproducing and redirected all of that same energy toward children she was already related to, grandchildren who already carried half her genetic legacy, could help ensure that more of her existing descendants actually survived to adulthood. In other words, more of her genes made it into the next generation through her grandchildren's survival than they ever could have through one more risky late-life pregnancy of her own. This flips the entire meaning of menopause on its head. It isn't a shutdown, it isn't a malfunction, it's arguably one of the most successful strategies in human evolutionary history, a redirection of a woman's remaining decades away from producing new children and toward keeping the children who already exist alive. Which means the support system for every human infant wasn't just parents and a handful of nearby helpers, it stretched across an entire generation that had by every other rule in nature already finished its biological job, and stayed anyway. Go back to that room for a second. The crib, the monitor, the door pulled shut, now you know what it's really hiding. Behind every one of those quiet, ordinary nights sits 300,000 years of an entirely different arrangement. One built on 14 sets of hands passing a baby back and forth. fathers staying close enough to touch, slings stitched from shell beads, and grandmothers who kept working long after their own bodies had, by nature's usual math, finished their job. Somewhere in the last few generations, all of that quietly disappeared, and what got left behind, more often than not, is one exhausted parent alone at 3 in the morning, wondering why something that should feel natural feels this hard. It's not that you're doing it wrong. Your body was never built to do this by itself. It was built for a village that, for most of us, simply isn't there anymore. So if there's someone in your life carrying this weight alone right now, a friend, a sibling, a neighbor down the hall, send them this video, not as a reminder of what's missing, but as an offer to be one more set of hands. And if this kind of question is the kind you want more of, subscribe. There's more of your ancestors' story still waiting to be told.